Hi, everyone, and welcome to week one of Introduction to Deep Learning. This week, we will explore what deep learning is, where it came from, and how it differs from traditional programming approaches. Let's take a quick look at how deep learning got to where it is today. So, in the 50s, researchers introduced the concept of artificial neurons, which is simple mathematical models inspired by the brain. This led the theoretical foundation for what we now call neural networks. Fast forward to the 80s, when the development of the backpropagation algorithm made it possible to train these networks, adjusting their internal parameters based on the error. But progress was still slow due to limited data and computing power. Then came the breakthrough in 2012, a deep neural network called AlexNet, right? Crushed the competition in a major image recognition challenge. It didn't just win, it cut the error rate in half, actually. That moment is widely seen as the start of the deep learning boom we're living through today. Deep learning is everywhere: voice assistants, photo tagging, medical scans, Netflix recommendations, and tools like ChatGPT. These models learn directly from massive data sets and improve over time. Let's break it down. At the top, we have artificial intelligence, the broad goal of building machines that can act intelligently. Within AI, we find machine learning, which is how we teach machines to improve through experience by learning from data instead of being explicitly programmed, right? Machine learning. And then within machine learning, we have deep learning, which uses multiple layers of interconnected components to learn powerful representations from massive data. The deep term refers to the depth of layers in the model, right? That's where deep comes from. Often dozens or hundreds of layers. Each of those layers learns something more abstract, helping the system to detect higher level patterns. So these layers allow models to go beyond surface patterns and understand structure, nuance, and abstraction, whether it's in the image or in speech or language. So deep learning isn't just deeper in layer, it is actually deeper in what it can learn. So deep learning models, they learn through trial and error. Imagine a kid or a toddler with a shape sorter toy, right? They try the wrong hole, they adjust, and then they try again. That's deep learning in a nutshell. They try something, right? Trial. They compare it to the answer, right? And then they measure the error and adjust accordingly. With enough repetition, it gets very good at getting it right the first time. This process is powered by what's called gradient descent, but we will explore the math later. In traditional programming, you write rules for the computer to follow, whereas in deep learning, you show examples, right? And the model will learn the rules by itself. That's what makes it so powerful, and why we use it for messy, complex tasks like vision and language. That's the main difference between traditional programming and deep learning models. Deep learning models are incredibly powerful and flexible, but they do come with challenges. First of all, they need large data sets, they can be biased, and they often don't explain their decisions. As engineers, it is our job to use them wisely and responsibly. So, in this course, you're not just learning what deep learning is, you're becoming the trainer. You will design models, experiment with them, and then learn from the process, just like the models themselves do. As powerful as deep learning is, it doesn't stand alone. The real breakthroughs happen when humans and machines work together. So, you as the human bring context, creativity, and experience, and of course, ethics as well. And then the machine brings things like scale, speed, pattern recognition that's beyond human capacity. So in real world applications, this partnership is really essential and crucial. So humans they get to define the problem, they curate and label the data, and they also get to interpret the model's results. And most importantly, they ask the right questions. So AI isn't here to replace you. It's here to amplify you. So smarter AI means human guided AI. Some deep learning is about learning patterns from data, not just memorizing, but recognizing what matters and what doesn't. It does this through layers and feedback from errors to gradually improve. And that's it. Everything we will explore from now on, which is architectures, optimizers, applications, they do build on this simple foundational idea.